Soldier boy, tough. Hey, I got this new dance for y'all called the Soldier Boy. You just gotta punch, then crank back 3 times from left to right. Soldier boy, I'm in it. Why me crank it? Why me roll?
A density curve is a curve that is always above the horizontal axis and has exactly an area of 1 underneath it. A density curve represents the overall pattern of a distribution. So in this case, this would be approximately normal distribution. This area would be 1. In some cases, the distribution would be skewed to the right, in this case, in which the mean is greater than the median. So if this is the median, it should be the mean. Other cases would be skewed to the left, in which case the median is greater than the mean. So this would be mean, this would be median. Density curves don't always have to look like that though. Density curve could be shaped like this, could be shaped like that. The area is still always going to be 1 underneath it.
Alright, as you can tell by this lovely density curve with perfectly straight lines, we gotta verify this is a density curve. So, to figure this out, you gotta find the area under this. So, I mean, the best way to do this is really kind of split this into sections here. So, take the point 2 here, and then multiply that here by 3. You get 0.6. So, like as you can tell, there's like 60 little 4 square sections under here. So the area under here is 0.6. And then looking at this area, you look at under this area, you kind of have it's a little more tricky because there's a triangle here, and there's like 2 squares over here. So like you can tell this is going to be 0.2, and under here is also going to be another point. You'll find it's also 0.2 because you multiply 0.2 here by 2, and then divide by 2, and you'll get that. So yeah, you can verify this is a density curve because if you add all these together, it totals up to be 1. Okay, one thing you need to do with different distributions is to be able to tell where the mean and median is. So, like, I'm going to draw out 3 bell curves here, each, like, 1 skewed left, 1 skewed right, 1 normal distribution. And I'm going to draw 3 lines here. And what you need to be able to do is to be able to figure out where the mean and median are. So, these are totally beautiful. They're just, the handwriting is just elegant, and the drawing. Okay, anyways. So first here you have a normal distribution, and with this, the mean and median are going to be the same. So it's going to be B right here. That's going to be the mean and median. However, this one's skewed left, so it's going to be a little different. So like, it's great. This here is going to be the median, and this is going to be the mean because the mean is going to be less than the median in a skewed left distribution. And in this one, it's skewed right, so it's the opposite. So A right here would be the median, and B would be the mean, because this would be greater than that. And C and A here are just outliers that are just kind of like, I don't even know. Okay, when looking at a normal distribution, there's 2 things you specifically look at when examining the data. You look at mu, and you look at sigma. Now, mu is the mean of the data, and sigma is the standard deviation, which is the average distance from the mean. Mu is always going to be given, but the standard deviation sigma you can calculate. So the formula for this is going to be the square root of the sum of like each x value minus mu squared. So you're going to take like every aspect of the data, or every piece of data, and you're going to put this in here, then subtract it from the average, and then square it, adding each of these values together, and then you do n minus 1, which ends the total data, and then minus 1, so that's pretty straightforward. And this is not going to have to be used too much, but it's there so that you know.
So, I'm going to be teaching you guys the empirical rule. Sounds kind of complicated, but to be honest, it really isn't that complicated. So basically, all normal curves follow this one rule, where a certain amount of data will be distributed within a certain percentage. So within one standard deviation, or sigma, of the normal curve, you will have 68% of your data. So essentially that means that 34% on both sides of the normal curve will be one standard deviation away from the mean. Now, if you're going to go for 2 standard deviations, you're going to be in the 95%. So you have here your 34% or your 68%. In this portion right here, which is 2 standard deviations away, you will have 95% of your data. So basically, within this portion right here, you will have 13.5% of the data, and here you'll have 13.5%. So far, if you have one standard deviation away from the mean, we're gonna have, that's where 68% of our data will lie. 2 standard deviations, we will have 95% of our data. Now, what about 3? Most statisticians say that it will be 99.7% of your data which falls in 3 standard deviations. So let's look at this in another bell curve. We have our normal curve right here. With this being our mu. Now, here and here, we are 1 standard deviation away from the mean. And how much is that? That's 68% of our data. If you got that right, good job. And between 2 standard deviations of our data, we will have 95% of our data, which will be basically all of this right here. And then the last right here and here, where 3 standard deviations away from our mean, we will have 99.7% of our data, which means that basically between here and between here, it will be 0.3% of our data will be here and here. 0.3%. That is a really low number. Also, they can be considered outliers. So that's the empirical rule, which is basically, for you to remember, 68, 95, and 99.7. I hope this helped.